Hi everyone, Mr. Allen here. I got an interesting question today, just kind of a general statement. How do I use double angle formulas? So first thing I want to say is I can't answer that question. Now the reason I can't answer that question is it's much like the question below. How do I use the fact that division and multiplication are inverse operations of each other? So one obvious answer to that, or one example, let's say, of a way we can use that is in a straight fraction division, 3/4 divided by 1/2. We can rewrite it and then use multiplication instead. But there are other ways to use that as well. Sort of this idea. If I ask somebody what is 1/2 of 50, some people might do 1/2 times 50. Some people might just kind of know off the top of their head that that's the same as dividing by 2 and actually do the division that way. This is probably an easier way for most of us to do this in our heads if the numbers work nicely. Okay, so that's kind of making use of the fact that you know instinctively or through experience that division and multiplication work together in certain ways. Now obviously if you know that, it doesn't always help, because if you get a question like what is 1/7 of 49.77, you don't know what number to divide by instead of kind of doing this. Or I guess you do, but maybe you don't recognize it right off the bat. That said, let's go through a few examples of double angle formula questions so that you can at least see some of the ways that we can make use of them. So when I see this question, cos of 2 theta, the first thing I recognize is we're in the section on double angle formulas. We've been given the double angle formulas, and so I can, with that, substitute one of these various other possibilities. Each of these, I'll say right off the bat, each of these is probably going to work fine for most questions. Sometimes there'll be one that is a little bit nicer to work with depending on what the rest of the question looks like. For this question, because there's nothing else, I'm not trying to compare cos 2 theta to anything else, then it's not gonna matter. When I get to identities, of course, there may be one of these that's a little bit easier or a little bit quicker to use, but as we've said many times, all of them will work for all of our questions. As long as we're not doing something illegal when we do a substitution with an identity, they will work out. So the question that was given was actually this triangle here, and given theta is 1/4, we need to make use of that information and then basically one of these equations to solve. So seeing that I see theta's here, I know that tan of theta is 1/4. I can determine what the missing side is here, what the hypotenuse is, and then I would actually have expressions for sine and or cos, whichever one I choose to use. And so in the solution, this is 1 squared plus 4 squared is 17. The square root of 17, just leave it as root 17. And so sine is the opposite 1 over the hypotenuse root 17. Cos is the adjacent 4 over the hypotenuse root 17. At this point you can see I still haven't used the double angle formula at all. That was just the information that was given to me. I know that I'm looking to use this eventually, which means that either cos or sine or both will be necessary in my solution. And then I think what I did here was basically showed 2, and in the notes there is a third. You can see the or here, there is a third solution as well. So just to show that it didn't matter which of the substitutions I chose. Cos theta is the same as cos squared minus sine squared. Given the original triangle, I know an expression for the ratio of sine and for cos, and so simply substituting those in and then manipulating the fractions, I come up with 15/17. Again, obviously I'll get the same answer provided I don't make a mistake in using the other forms of the expression as well. So that's the 2 cos squared minus 1, and the example that's got cut off is the 1 minus 2 sine squared. And again, all three work out to the exact same answer. Question 19 here. So again, I see a sine 2 theta. So I have some different options available to me. The first one is I can do the substitution sine 2 theta for this, and then basically determine whether that's going to help me. I don't know how to solve for sine 2 theta as easily as I know how to solve for sine thetas and so on. So if I make that substitution, I've got sines and coses in which I'm more comfortable with. Just like when we did the identities, I said starting with converting to sines and coses is probably the nicest way to go. I now see that I have a common factor of sine here, so factor out the sine, I'm left with 2 cos theta minus 1, and now I have that expression, or that form that I'm always looking for. Two values multiplied to 0 means that one or the other has to be equal to 0. So sine x is 0, or 2 cos x minus 1 is 0, so cos is 1/2. And this question was, or suggested anything in the 0 to 2 pi range we're looking for solutions. So sine is 0 at 0, and then at 180 degrees, which is pi. Cos is 1/2 in quadrants 1 and 4. And so in quadrant 1 it's pi over 3. In quadrant 4, I didn't actually draw this one in. I should have, I suppose. In quadrant 4, given our butterfly, I'm going to do this quickly. The pi over 3 is right here. And so that means I'm rotating all the way around. This would be 6 pi over 3, or sorry, this would be 2 pi total, so 6 pi over 3. I subtract the pi over 3 to find that the angle here is 5 pi over 3. Now I've said this to a few people, I guess I'll say it at this point as well. If you are handing this solution in on a test, either this year or in the future, I would say definitely you want some sort of an indication here as to how you found the 5 pi over 3. I didn't put it because I'd already done it a couple of times earlier in the, well, several times earlier in the unit. But for an actual hand-in get marks question, definitely indicate something. I would suggest never just having a new number appear in your solution as, oh yeah, and obviously 5 pi over 3 is part of this as well. 29 and 31 here are pretty quick, and again, just different ways to make use of this. When I look at each of these, I see something that looks like one of my double angle formulas, but going the opposite direction to what we've typically done. So this right here, sine times cos, is here. This is 2 times 3, so I can think of it as 3 times 2 sine x cos x, which would be 3 times this thing, which is sine 2 theta, or sine 2u as written there. Same sort of thing with this one. If I factor out the 3, what I'm left with is cos squared minus, or sorry, 2 cos squared minus 1 right there, which is the same as cos 2x. Now again, all I've done here, or I haven't really solved anything here, all I've done is rewritten the expression in a slightly different form with the idea that that might help later on. It might allow me to, if I'm programming this into a computer, program a slightly smaller expression, or if this is part of an identity, it might allow me to recognize that this is similar to something on the other side. Just an option that's available to us. Knowing that these double angle formulas exist means we can substitute one for the other at any point in time. Whether it helps depends on the question, and which way we prefer to go depends on the question as well. Now this question pretty simply said, find, given the fact that we know secant u is -2 and that u is in the second quadrant, find values for sine 2 theta, cos 2 theta, and it actually said tan 2 theta as well. Typically we won't do that, but there was a way to do it fairly easily here. Given that secant u is -2, so again, before we even get into the double angle formulas, in this case, as I said, we're specifically looking to find the double angles. That's what the question actually asked. But given that secant u is -2, we know that secant is 1 over cos. So kind of going across here, secant u is -2. That means that the hypotenuse divided by the adjacent is -2. So your hypotenuse is the 2 here, the adjacent is the 1, and then using a little bit of math, Pythagorean theorem, we can determine that the opposite is -3. Now again, given the fact that we're asked to find sine of 2 theta, cos of 2 theta, and so on, we don't have that information yet. The triangle allows me to quickly determine what is sine of this area, sine of this angle, cos of this angle, and tan of this angle, but not actually what is sine of double that angle. So knowing that sine 2 theta is the same as 2 sine cos, we can use that to determine a ratio for sine 2 theta, -√3/2. And then again, same sort of thing over here with cos. Having a formula for cos, 1 minus 2 sine squared theta. I chose that one just because I happen to choose that one. Any of the other two, or either of the other two, would have given me the same answer. Sine of u is opposite over adjacent, √3/2, and then simplifying gets me to -1/2 being the ratio for cos of 2u. And then just sort of a simple thing here. In this case, we don't have a formula for tan of 2u. Oops. Apologies. We don't have a formula for tan of 2u, but we know that tan of any angle is the same as sine of that angle divided by cosine of that angle. So taking our two solutions from the first parts, we can divide them and find that √3 is our solution for tan 2u. So whether that's going to help, I can't say. The big thing to understand again is that these are double angle formulas, and any of the identities we've seen are just facts. This is exactly the same as that. And so anytime we have one of them, we could substitute the other instead. Anytime I see 2 cos squared u minus 1, I could replace that with cos 2 theta. Anytime I see sine 2 theta, I can replace it with 2 sine theta cos theta. Whether it helps depends on the individual question, and which way you want to go determines on what information you have. Generally speaking, if you have information about an angle, you want to be getting rid of your double angles and dealing with the individual angles. As soon as I know one ratio here for secant u in this case, or any ratio for the angle u, then I can quickly and easily find sine u, cos u, tan u, and so on. So for that, I wouldn't want to have the double angles involved. I'd want to make the substitution. Sometimes maybe we want to go the other way as well. Again, dependent on the question. So I'm going to stop there, and hopefully that helps a little bit. If it doesn't, maybe a more specific question I can focus on next time.